Hello, this is Lawrence Romanosky from Calgary, Canada, and this is Electric Vehicles 101, where during the next 2 hours or so, we will take a deep dive into the electric vehicles for sale globally and the ones in Canada. We'll go into their construction, charging, range, all of the useful information and metrics. I can summarize it for you by just going through this slide deck really quickly so you'll know what to expect. We will start with electric vehicle sales and market share. Go through AC and DC charging options, DC charging infrastructure, DC charging curves. We'll go into the different kinds of battery packs, what kind of cells are in them and how the chemistry is different. We will explain the difference of 400 volt and 800 volt architecture. We'll go through different units and measures, including power, efficiency, how the EVs deal with cold weather, what the consumption is like, cost of operation. We'll look at EV design and the skateboards, how they're assembled, different factors that go into them. We have a list of questions here. If you're looking for an EV, what are all the questions that you're going to want to ask? We go through a selection of EV models, look at the skateboard platform and the variants that are built upon them, and do a general cross-section of some of the EVs available today. Then we get into a big spreadsheet showing all the EVs that are available in Canada, all of the different capacities and units and performance measures, range. And what I've done is I've calculated the driving to charging ratio for each vehicle and the amount of time that it would take to drive 1,000 kilometers, including charging for each car. So I've got about 100 cars here. We've compiled all the information, and this will take about 2 hours and a little bit to go through. So it's a deep dive. I call it Electric Cars 101. Some of the people I presented this to suggested it might be a 300 level course and not a 100 level course. But if you're looking to adopt, if you're looking to get into e-mobility, to buy an electric car, there's a little bit more that's, I think, required to get your head around some of the numbers and some of the metrics. And I think you do need to invest some time so as you're not disappointed, and that you make sure that the car you're buying, the variant you're buying, the options in the variant you're buying are what you think they are, and whether they're going to suit your needs or not. So if you're interested in EV and prepared to take some time and effort to understand it, then I think the next 2 hours plus, would be very beneficial to you. And I hope you enjoy the presentation and get something useful out of it. There will be a link below to this information in an online flip magazine or slide deck, so you can access the information as well. Okay, thank you very much. Lawrence Romanosky, and I am from, or the magazine that I created was Soleil, which I'm endeavoring to make Canada's electric vehicle buyer's guide, and the contents in this presentation will make it to a digital version of this magazine, which will also be in the link when it's finished. Thank you very much. Lawrence Romanosky from Calgary, Canada. So I didn't want to spend too much time on all of this, but there's a couple interesting things. This is EV sales and EV market share, and you see it goes from almost nothing.
Is this worldwide or Canada?
This is global, and we're at 13 now. So, but they estimate that by the end of 22 we'll be at 13%. Okay. So obviously that is exponential, and then you can see where that growth is, and it's mostly China and Europe, North America a little bit, okay? And then if you look at that other slide, what's interesting is the number of Chinese manufacturers that make up the volume of EV sales. No real surprise when you see most of the EVs are sold in China. That's plug-in vehicle sales, which also include PHEVs, so the plug-in electric hybrids. And what's interesting is you have to go pretty far down that list before you get a Japanese manufacturer. And normally when you get a list of anything with cars, the Japanese manufacturers are, dominant at the top, right?
Is that Toyota?
Yeah, it's Toyota. That's how far you have to go. And they just started selling an electric car
But
in
they're
North
not
America.
really vested in the whole EV thing.
They're not fully vested. They took the approach that the EVs were just too expensive. They didn't want to invest in it. They thought that their customers' transportation needs were better served with the hybrids, so they put everything in their hybrids. But now there's some serious backtracking, and now there's a rush to make 50 EVs and get them on the market in a few years. So they've had to really walk that back. And Honda's nowhere. They've got their little Honda city in Japan. They don't even sell a BEV in North America.
Is it Audi, Porsche, or just Audi?
That's just Audi. That's not the whole VW group. Okay, so globally we're at around 20. Globally we're at 13. China leads it at 20. Europe's about 20. There's some individual countries in Europe, like Norway, that's like 70% just because of their favorable taxation and incentives and so forth. Canada, for North America, is 6. Canada's 5. And in Canada, it goes anywhere from like 1% or less than 1% in Saskatchewan to like 20% in Vancouver. Okay, so but in Saskatchewan is less than 1. Alberta might be 2 or something like that, and then just about all the EVs are sold in Toronto, Quebec, and Vancouver, and of course Vancouver and Quebec have big incentives for the EVs. Many of the manufacturers, they don't even sell the cars in Alberta. So you can't buy a Polestar, and you can only now just buy a VW ID series. And they're rolling it out in Alberta basically last.
And that's one of the reasons I was so comfortable with the Rivian, is because Rivian's actually building their service center here. They've actually got the plans. I've seen the plans.
Yeah, okay.
Where their land and the plans for the service center here.
Right, so Rivian, I think they built the new EV startups, Lucid, Rivian, VinFast. They're just now building showrooms, but really just Ontario, Quebec, and BC. But they're setting up the network of service providers.
Yep,
So,
and that's in Vancouver. They just had the Rivian road show
Yeah.
a week ago or something.
yeah. Oh, it's great. It's a great truck. Other interesting things about that, BYD was number 2 on the list. It was like nowhere a few years ago.
Is that China?
Yeah, China. No. The rate at what they're making cars is unbelievable. The semiconductor chip shortage that's affected just about everything, okay, they solved it by making their own chips. Okay, making your own chips is like $10 billion. You guys know that. You're both in technology. It's like you can't just make semiconductor chips. Like it's 10 billion. But anyway, they did. And then they bought 7,500 car shipping vessels. They ordered them for almost $1 billion to haul their cars around.
So who's funding them then? Where's all the money coming from?
Well, it's
Chinese government?
stock market, or okay. Now BYD got into the mask. During COVID, they started building masks.
Right.
So 3 days they had the prototype. 7 days they built all their machines to make the masks. In 30 days, they're turning 100 million pieces a day.
There's a good documentary online. I don't know if it's on Netflix, but actually of that factory turn. It's great. It's the craziest damn thing you've ever seen.
So VinFast, they're not even making them. VinFast is this Vietnamese guy who moved to Ukraine and started selling noodles, and then came back to Vietnam and started buying real estate, and then diversified into hotels and amusement parks and luxury resorts and building homes and finance company and artificial intelligence and everything else. Decides to build cars, hires Pininfarina to design it, hires Siemens to build them a factory. okay? Hires Magna to build a car, licenses the technology from BMW, okay? They've got a prototype, finished prototype at the auto show in a year. They build the factory in 18 months. They're selling their first car in 2 years, and they roll the thing out globally in like 4 years. From nothing. Like from nothing. So, I'll get into some other slides as well, but the consumer electronics companies also are building EVs. So Foxconn, it's like building, well, Foxconn had sales of $219 billion last year. They make all the iPhones and iPads and most of the gaming consoles. $218 billion. CATL, C-A-T-L, is a Chinese company. They're the leader in selling batteries. Okay, 30% of the market, just about every car is CATL batteries. They're making their own skateboard platform. So if you want to build an electric car, you can just go buy it, put your body on it. You can go to Magna, like Fisker did, and get them to make it. There was a company, Lordstown, that was making trucks. They ran into all kinds of problems. Bought a factory from GM. Well, Foxconn bought that factory and is making the truck for them. Fisker wants a little car, like a city electric car. Just get Foxconn to make it for you, just the same way they make an Apple phone or an iPhone.
Yeah.
So anybody can make an electric car now. They all, as you'll see, very similarly designed and manufactured. And the Chinese and the Asian companies, like they get their act together. Like a worker in Vietnam makes $800 a month. And their work week is 50 hours and 6 days a week.
Right, so try to do that in North America. You couldn't.
Resistance, yeah.
Well, not only resistance, but you couldn't. It would cost them $80,000 to produce the car, right? Because of the labor costs and retooling and manufacturing associated with that platform. When your labor costs are $800 a month.
Yeah, no,
But there's probably less labor costs in a EV car than a traditional car, isn't it?
yeah, especially if you don't make any of the components yourself.
Right, if you're just
put it
putting shit together.
Yeah, it's like an FX kit.
Yeah.
Okay, so
Does
you
ACDC
like my
build it?
logo? I know. I said, well, if I'm only doing this here, I don't have to worry
I
about
love
the
it.
logo.
It's awesome.
All right. So AC and DC, alternating current, direct current. So forgive me for going back to basics here because it's online. But AC, of course, is what is in the electrical grid. AC is what your house gets. AC is what powers all your household items and so on. AC cannot be stored in a battery. You can store AC mechanically. There's all kinds of ways to store electrical energy,
Sure.
but not on a battery. For a battery, you need DC. So that means that every vehicle runs on a battery, runs on DC. All the components in the car are DC, etc. Okay. Now, the EVs, they're going to need DC in the battery. Okay. They're going to be charged AC at home and DC. All right. The stereo and the blower motor and the seat heater and the wipers and all that are DC, but the electric motors that run the car are AC. All right, so
low voltage DC, right?
So and then there's different voltages. Okay, so you have 12 volt low voltage system, and then you have your high voltage system. So you're pumping in AC into the car, it gets converted into DC to store in the battery. When it goes somewhere, the power electronics convert the DC into AC, and now the car moves. And when you lift off the throttle, you have the regenerative braking so that the energy is recouped at AC and then converted back into DC. And then it's managing, the high voltage transmission of the current. But then it's also powering the low voltage stuff in DC. And then if you and then it depends on, you can charge it at home at AC or on the road at DC. And so the car, the whole entire time, is converting AC to DC and DC to AC and converting voltages and stepping up voltages and stepping down voltages. Oh, the other thing is that the charging stations, the DC charging stations, can be 400 volt or they can be 800 volt, okay? So the car is very busy changing one type of electricity current voltage to the other, and anytime you have any of that conversion, it generates heat.
So you can't plug a 400 volt platform into the 800 volt charger?
You can, it's just that there's a bottleneck then because it's got to convert it. It's got to step up or step down the voltage. So if you have a car that advertises, like the Porsche or something, or the Hyundai for that matter, 800 volt, and that it can charge at 250 kilowatts.
Yeah.
Okay, well it's only going to do that at an 800 volt station, not a 400 volt station. And they don't tell you what's 800 and what's 400, even on the apps. So you just kind of have to guess, or maybe some of them, but mostly they don't. So it's only the Electrify Canada and Electrify America stations and the Ionity system in Europe that runs 800 volt systems. Now, there's a reason for that, and the Electrify Canada and Electrify America stations are owned by the VW Group, and that was part of the Dieselgate settlement, where they agreed to spend $2 billion on infrastructure.
Right.
And to try to eke some sort of competitive advantage out of it, they made their cars 800 volt and the infrastructure 800 volt, giving their cars an advantage. There could be other reasons as well.
Why wouldn't you? Yeah.
But what about so the Canadian government just talked about building or investing in fast charging stations.
Yeah, so I don't.
Rivian says they're building their own in Alberta and BC.
Right, so there's a whole bunch of companies that are building fast charging stations. I mean, the big ones are Electrify Canada, Petro-Canada, Shell's announced that as well.
Okay.
Tesla has their own proprietary system, and the government of Canada has grants to offset the cost of charging stations. I haven't heard that they're building their own stations. I doubt that.
I wonder if maybe that's what it was the incentives.
That they have incentives to do that,
Yeah.
for sure. Okay. So now, when you get the AC into your house, most houses have 100 amp service or 200 amp service for most houses, and then that is broken down into amp circuits, or so many amp circuits. So usually the 120 volt, it used to be 220, 110 and 220, and I think in the 60s they started upgrading it all to 120 and 240. But everybody still talks about 110 volts or 220, but it's actually 120 and 240. And you can wire these up depending on how you do it. So you can have a 120 circuit that's dedicated. Okay, so it's, there's only one thing on it. You can have a 120 circuit where there's lots of stuff on it. You can have a 120 circuit that's 15 amps, which is normal, but you can also have a 120 that's 20 amps.
Yeah.
Okay. For the 240 volt ones, if you do the 215 together, you get 30 amp. So that's the most common, but you can do 40 amp and 50 amp, and it depends on what you're hooking up. For normal washers and dryers and those are normally 30 amp, but for instance, for our AC unit that we put in, it needed a 40 amp service. Okay.
Yeah.
So the power, watts, is equals to amps times volts. We know the volt is, for say, on a level 2 charger is 240. So the amount of kilowatts on the plug is going to be determined by the amp circuit.
By the breaker, yeah.
Okay. So, and the way you figure that out is just, watts equals amps times volts. So you just take the 240 and you're going to times it by either 30, 40, 50, 60, or 100. That's going to give you the kilowatts. However, the electrical code requires that the continued draw on that circuit be limited to 80% of it.
Yeah.
So it's the 240 volts times the amps times 0.8. In your example of a 240 volt circuit with 50 amps times 0.8, you get 9.6 kilowatts. Okay, so the constant draw out of the wall is 9.6 kilowatts. Okay, and then you're sticking it in your EV. Your EV is going to have some power electronics in it, that are going to determine its capacity to take the AC current into the car, change it to DC, and feed it into the battery. And the cars are different. The modern EVs, most of them, are all stuck at around 11, okay, 11 kilowatts. That would necessitate a 60 amp breaker, and I think that comes in at 11.5 kilowatts. So for most cars, the most AC you can pump in it is going to be 11 kilowatts, no matter how big your breaker is. So 60 amps is the kind of the effective maximum that you can do.
Yeah. If you want to charge your car the fastest, 240, 60 amps.
Yeah. Now, there's a couple cars on the market where you can, where they go up to 19.2. The Ford F-150 Lightning goes up to 19.2. The Lucid, which is kind of the best of everything, cost no object, it goes up to 19.2. Actually, the Rimac too, you get €2.5 million euros to spend on that. You can charge it at that. The Taycan actually too, as an optional AC charger. You have to look at the specs on the car pretty carefully because different, they might have 5 or 6 different specifications and options. And often the higher charging onboard electronic component is buried in the option list somewhere. For instance, on the Taycan, you'll read about the Taycan and it'll say, well, it'll charge at 270 kilowatts. All right, great. Only at 800 volt. Okay.
Right.
If you go to a 400, it's 50 kilowatts. So you go to Electrify Canada and you get 270, and you go to Petro-Canada, 350 kilowatt station. You think, oh, I'm going to get this huge amount of charge, and it's 50, unless you tick the box for like $800, and then you get the optional 150 kilowatt DC charger. But if you don't tick the box, you're showing up in your $250,000 EV at a 350 kilowatt charging station, wrestling this cord that's like this big, liquid cooled, sticking it in there, paying by the minute. You don't even pay by the kilowatt, you pay by the minute, and the thing's stuck at 50, and you wonder what you did wrong. Okay, well, you didn't check the box for the onboard charger. Okay, so we're gonna decide when you get your EV and you find where you want to charge it. You're going to figure out what you need for to buy your box, your EV charge box. They're like $600 to $1,200. Each of these boxes has a limit. Okay, so some of them might only be 7 kilowatts. Some of them might be 20 kilowatts. Most are 11, but not all of them are 11. So you need to see what the capacity of these things are. Okay, and you go to Amazon, buy one, and it's there the next day. Okay, it's easy. Then you got to get it hooked up. Now each house is going to be a little bit different, and I think we all live in old houses, and so there could be a big step up to get a certain amp circuit, but you can share circuits. Okay, so with us, we have 100, grandma bungalow, 100 amp service that's been upgraded. And we had a 40 amp panel for the AC, 40 amp service for the AC. But there's no room left on our panel. It's completely full. Can't do anything with it. Every circuit is being used.
I brought mine in the garage specifically for a welder. So that service, that 240 I brought into the garage, I've also got, that runs the garage heat and all the standard 110 plugs.
Right.
So I can run, like I said, I'm pretty sure I can go to 60 on that panel and just straight for charging. That's all I use it for.
Right. Now, what you can do is you can have load sharing devices, a typical day for us, I charge our EV to 90% to be nice to the battery. My wife runs it down to 80% or 70% or something like that. We've got to put in, 10 or 15 kilowatt hours into the battery. We're charging at 7.5 amps. That's a couple hours, right? Well, we park the car at 5 o'clock. We don't use it the next day until 8. It doesn't matter when we charge the car. It can be any time. If electricity was cheaper at midnight, we just tell it to charge at midnight. It's only 2 hours.
Oh, right, because you can set the time, that's right.
So you can set
Yeah.
the time. Okay, so, you know, in our case, we can't use the AC at full blast and charge the car at 7.5 kilowatts. And our load sharing device would then divert, you know, whatever power it can to the car, but let the AC work as much as it wants to. But we don't need to, doesn't need to be that way, because I'm not going to be using the AC at midnight, you know. So if I did have a conflict with that, I can manage it by, you know, setting the start and stop time of our charger. Okay.
Right, or you can end up doing what I do, is have a separate service.
Or you can have a dedicated service. But
Right.
if your house is maxed out, you know, and you know, you can share the circuit with something else.
Right, yeah.
Now you're
And
probably,
in my case, it's not designed like, so the house, power going to the house is the power going to the house, the power going to the garage is power going to
yeah,
the garage.
okay, so then you've got your own,
Yeah.
your own circuit. And you're not going to be welding continuously
No,
for 7 hours.
no, I don't weld anymore anyway. So.
All right, so, okay, so you decide that, you have a conversation with your electrician. He says, oh, no problem, you have lots of excess capacity. You just built a new house, you have 100 amps that nobody's doing anything with. We can easily have a 60 amp breaker, you know, to your garage. And then you think, okay, well, you know, I'm gonna get the optional, you know, or 100 amp for that matter. You can get the optional onboard charger for, you know, maybe a car that can handle 19 kilowatts. More likely you might just say, oh, let's max it out and future-proof it. I'll put a dedicated 60 amp service to the car. But then you gotta be careful in that you buy the EV box that'll also handle
Right.
11 kilowatts. And then you have to make sure your car can accept 11 kilowatts, so it needs to be balanced throughout this chain.
Right,
All right.
and you gotta check the box when you buy it.
And you don't need 19 kilowatts AC unless you're a contractor running your Ford Lightning and, you know, you need to bring it home or to your office and get a full charge in a few hours. I mean, normally you just don't drive that much. I mean, people drive 20 or 30,000 kilometers a year.
Yeah,
You
it's a
know,
lot, yeah, more than the least, right?
That doesn't equate to a lot per day.
Yeah.
And you know, like I said, between 1 and 2 hours a day is all we need to recharge our EV. Even if we drove it twice as far one day, even if we drove it twice as far in the worst weather one day, even if we, you know, whatever, it'll still charge overnight at 7.5 kilowatts.
Right.
So I can't really see any reason why I need 19 kilowatts, even if it was available. And for us, 40 kilowatts sharing with the AC, 80% of that, 40 amps with the AC, 80% of that's 32 times 240 is like 7.5, and our car gets 7.5. That's 1 or 2 hours of charging per day. That's fine. It could be 5. We don't even need.
You're nowhere close to having a conflict.
Right. Okay. So, but I guess the takeaway is you're matching the service in your home to the charge box to the onboard charger of your car. All right. Connectors. Okay. So Tesla's got their own system, own superchargers, own home charging, own hardware. There's adapters. Okay. But the adapter normally has a limitation. So you know, if you try to use an adapter to charge at a Tesla station, and your car might get 150 or 200 kilowatts, it's usually 40 or 50 kilowatts or even less. So you can use an adapter, but they really throttle back the amount of amperage that you can get. This is a J1772. That's the standard. Okay, so this Chatamo was more a Japanese design. Okay, and only the Mitsubishi and the Nissan Leaf use Chatamo. The Nissan Leaf still uses Chatamo, and Mitsubishi, I don't even think they sell EVs anymore. And so this is kind of gone. You'll see it when you go up to an Electrify Canada or Petro Canada. They'll still have the provision for charging at Chatamo. The maximum from any Chatamo is only like 50 or 60 kilowatts. So it's just old, dead. Nobody's using it. It's gone. But if you go buy a used Leaf, you'll need a Chatham. Everybody else is using the J1772. It's not from Tesla, it's got nothing to do with Tesla. Sorry about that. So everybody else is using this. And this bit here is the AC part, okay? Now, if you take a J1772 and you add DC charging to it, what you get is CCS, where this bit here is the same as the CCS and fits into the same port, but this is the DC. So these two pins and this oval section is the DC fast charge. When you're charging at a DC fast charge station, this does nothing, and all the power goes through there, okay? Now this port, and we can see that on the Ionic, this port is used for the J1772. So at home, you take this port, and it goes in there, okay? And when you're DC fast charging it, you take this CCS connector and plug it in. Usually there's a flap covering that, so you have to take the flap off to access these.
So does that, so if your car comes with your car comes with the CCS or the J1?
Well, they're both the same, because the car comes with CCS. That's the port in the car, okay?
Yeah.
And when you get the 120 volt cord, it has the J1772 connector.
Got it.
That's what's in the car now.
Got it.
Okay?
Yeah.
But, and actually, you can have the wall boxes also have this as well. Okay, so when you're charging from home, this is what you get. This is what comes with the car. When you charge DC fast charge from the charger, this is what it looks like. Now, I don't know why they need this for the DC charger. I don't know why that is, but they made a CCS combination, presumably because there's some places where, you know, it might, maybe there's some cars that only take AC on fast charge stations, so they need to have this. But normally, for any of the cars I know of, you're just charging with this bottom here, and that's DC. Okay. AC is pretty stable. Like it just, this says it decreases after 90 to 100, and I think that's the power electronics in the car that monitor that. I can't see any difference between the charge time from 80 to 90 and 90 and 100 on my car. It could be that I'm only charging at 7.5 kilowatts. That's not enough power to do anything. It's not going to heat anything up too much, so the car doesn't care.
Right.
It doesn't need to throttle back. As you step up the power and you heat up the batteries and you heat up the power electronics, the car starts to get a little bit more concerned about what's going on, and then it throttles back the charge it'll accept. And it has a bunch of work to do to balance out all the different cells in the batteries and so forth. And when you start getting up to really high voltages in DC, it does all kinds of crazy things with the voltage to make sure that it doesn't overheat. So with AC, it's totally consistent, at least in my experience. You can count on a certain number of kilowatt charge. It's repeatable every day. It doesn't seem to make any difference what temperature it is. You know, and our car's charged outside. You know, if the thing, the maximum is 7.5 kilowatts in our case, and I plug it in for 2 hours, you know, I'm getting 15 kilowatt hours in the car no matter what. Okay, I can count on it. DC is all over the place, and you have no idea if the station's going to work, if it'll take your credit card, if it'll connect, how much power you're going to get. I wouldn't quite say at this stage it's a lottery, because I mean, you'll get to know your car, you'll get to know the stations and so on, but it's almost impossible to tell what it's going to give you. And you really have to totally geek out on your car.
Doesn't the car track that? So when you're charging, you can take a look at it after the fact and see what happened with the charging, so you can determine how much power you got at what time and how it did it.
I'm sure there's gotta be
Some cars do. I think the Tesla, you can download all that stuff. and you could download charge curves and stuff like that. In my car, you can't.
And, you know, and I'd be willing to bet that someone will come up with an app that will that will actually track your charging efficiency
Right.
at each one of the stations, so you can actually mark it in the app saying, well, yeah. So
So
my question would be, are they upcharging for the use of DC power, fast charging?
they charge you by the minute. So if it's a crappy day and it's cold out and your car doesn't want to take any charge, you'll roll in, you'll get 40 or 50 kilowatts.
That's a
You'll be losing your mind,
That's a great
Business model.
scam. That's a great business model.
and you'll be losing your mind because your car takes 250 or 270 kilowatts, and you roll in and it's
40.
costing you 50 cents a minute, and you're not getting any power. So by the end of it, the electricity is costing you just as much as gasoline, and you'll be like losing your mind. Other times you come in and you're like, whoa, this thing never charging fast, and you get your number up in the 200s and you feel really happy. Okay.
Yeah,
But
so you might have to pull out the Excel spreadsheet with your laptop as you go to these, right? Sort
it's
yourself.
mostly temperature related, and it's it's not only the ambient temperature, but it's also the temperature of the battery itself. I think what happens with the DC charging sessions is that the kilowatts are much higher, the charge rate's much higher, and the car is managing the temperature because it's getting hot really fast.
Got it.
And the battery will only take a certain amount of charge if it gets up to a certain temperature first.
Right.
So if the battery's cold, you get a slow rate. If the battery's hot, you get a slow rate. Okay?
So you'd have
And so,
that perfect median temperature.
and then it also depends on the service into the charging station, how many other people are charging, and who knows, a whole lot of other stuff besides. Okay. So, all right, so we've got through that. Now this is, if you take a look at this graph, this shows you a Porsche Taycan, that's 800 volt, okay? That's this one up here. Tesla Model S, Model X, Hyundai Kona, so that's not one of the latest ones, that's an older one, VW ID3. So the only one of these that's 800 volt is the Taycan, okay? And all these charge curves represent the kilowatts that the car receives at what the state of charge is. Okay, so if you're into trying to predict how much charge your car is going to get, you're going to need to be familiar with the state of charge. And so you might think that, oh, my car's rated for 250 kilowatts. You might think you plug it in at 250 kilowatts and it just stays there, but it doesn't.
Well, with the exception of the Audi and the Porsche, they all drop off at around 50%.
Yeah, so the typical charging station will see the car. If you let the battery go down, it'll start pretty slowly. It'll ramp up to its maximum at like between 10 and usually 20% of charge. Then you'll get this slow decline, okay, until it hits 80, and then it really drops off, okay? And the reason it does that is that's the car is protecting itself, so it doesn't heat up too much.
And to give you some power early on, so that if you have to go, you can.
I don't think it's got anything to do with that, because most people don't let their EVs go down to like 5% before you charge. Like, you just wouldn't do that. Like,
I don't think you know most people, so.
I'm gonna raise my hand and say, I'm that guy. Oh, there's an eighth of the tank left.
okay,
We
but
can make it to the next
you're on the
one.
highway. The next charging station is 100 kilometers away.
Right.
You don't know if it's going to work,
Yeah.
because it might be broken, and they are broken. And if it does work, you don't know how much charge, how many kilowatts you're going to get out of it, and you don't know who's already charging there.
Yeah.
So, are you going to chance it?
Keep driving until it goes. Yeah.
Or are you going to hit 50% and think, you know what, I'm gonna top up here.
Yeah.
And so I don't know most people, but from what I read, most people are just gonna charge wherever they have an opportunity. You know, instead of like, you know, risking going all the way down to 5% and then just hoping that your charge station's there based on an app you might have that says it there, and the app might not even be right.
I think you're estimating how intelligent people are.
Now, it can go wrong. One guy that I talked to with a Taycan pulled into his charging station, plugs in, and the charging station is part of this complex. There's a gas station, there's an A&W, and he plugs his Taycan in and takes out the power for the A&W and the charging station. Walks in, and all the
I
lights
mean,
are
if you
off.
own a Taycan, you better walk in like, yeah.
It's like, you're kind of walking in and going, oh.
Oh, no, I don't it, I don't it.
What happened here? All right, but anyway, so the manufacturers quote 20 to 80%, because that's where the charging curve is the meatiest, okay? And nobody's gonna say, oh, my car will charge 80 to 100 in 2 hours, you know, but because it really slows down, and it slows down at the beginning. So this is the window where you normally charge 20 to 80%. Okay, that's where the you know, you get the highest average charge. You know, if you wanted to, we'll get into this a little bit later, but if you wanted to really minimize your point-to-point times, and let's say you had a car that could, like a Taycan, that could get over 250 kilowatts, and you knew that at 45% it started dropping off, and to minimize your charging time, maximize your distance, you'd be like, okay, I'm running this thing down to 20, I'm charging up to 45, and then I'm back on the road again. Because then overall, you'll spend less time charging because you're going to be charging at 250 kilowatts. And if you charge at 250 kilowatts, you know, for, you know, and your batteries, you know, let's say you're putting in, you know, 20 to 25 kilowatts into your car, and you're charging in 250 kilowatts, you're going to be charging, putting that 25 kilowatts in 1/10 of an hour. You're not going to be there for very long. Okay.
Unless you're like me and you're driving that Taycan like it's a 911 turbo.
So most people would probably bring it up to 80 and get back on the road. It's a little bit bad form to sit in the charging station and let it eke out 10 kilowatts and sit there when you have a lineup of people behind, okay? So it's good etiquette to leave the charging station at 80%. When you go to these charging stations, and there's some over there, you have a choice of 150 or a 350 kilowatt usually, okay? And they're different prices, okay? It's also bad form that if your car doesn't have a hope of ever getting more than 100 kilowatts, to park yourself at the 350 kilowatt station. Because there's somebody who can use that power. And so that's kind of a little bit bad form. What I see though is that there's not a whole lot of difference between these two, because, you know, if I took my cars rated at 240 kilowatts to a 350 kilowatt station, the time that it spends at over 150 isn't that much. And I kind of like to charge my car, you know, in this range anyway. So we're talking about like 3 minutes on a charging station.
And so that's the equation, right? Is how much longer will it take you to get where you need to be at 150 kilowatts, as opposed to how long will it take you to get to where you want to be charging 350 kilowatts, because it's twice the price to charge at 350.
Yeah, and like a Tesla, or there's some other cars, I think the Rivian's at 200 kilowatts,
I don't remember.
but it's 400 volts. The Teslas are at 400 volts. The Teslas have a peak charging rate of over 200 kilowatts. But if you look at where a Tesla is, yeah, it is a peak charging rate of 250.
So
then it gets super hot,
Yeah.
and then the car backs the thing off.
Off to down to 200 down the
So
road.
it's not there for very long, and it's only there at a 5% state of charge, which means, like, if you're driving in the city, you're charging from a home. You're not going to a DC
Yeah.
fast charging, okay? The only reason you're on a DC fast charger is because you're on the highway. Are you really gonna go down to 3% charge just to get your 250 from 3 to, 10? Only maybe if you're running a YouTube, you have a YouTube channel or something, you wanna see if it'll make it, and you've got a recovery truck and a bunch of friends to push you if you run out. But, nobody, I don't imagine that most people would ever take advantage of that. I just don't think they would.
I don't think most people understand the curves, so it's.
Well, once you understand, you kind of look at the math, you kind of go, oh.
Now, the other thing is that this is heavily dependent on the ambient temperature, okay? Like it can be half of this. And there's a certain amount of like just black magic in it all. Like go to the same station twice, it's the same temperature, it's this, the same state of charge, you do it and you get two different results. Way different results. Like they're way different, they're not even close to being the same. Okay, so this is, like I drove a Taycan for, I tried multiple sessions at both Petro-Canada and Electrify Canada. I never got anywhere close to that ever.
Wow.
Like ever. I didn't get over 200. I was down here. Okay, like not even close to getting that. It is possible, but the conditions really have to be perfect and specific. The battery wants to be like 30 degrees. It doesn't want to be 25 or 20 or any less. Doesn't want to be any hotter than that. Okay, and everything has to be aligned for you to get that. Now, the battery normally isn't 30 degrees. The battery might be 20 degrees or something, even if the ambient temperature is hot. Okay, so some cars have battery preconditioning. Okay. So they'll bring up the temperature of the battery so that it's at the ideal temperature before you DC charge. And then when you DC charge, you'll get the maximum rate. Some cars, like the Tesla, put that in sophisticated range planning. So you put in your start destination, your end destination. Yeah. It plans the routes, it knows where the superchargers are. It is pretty good at telling you how many kilowatts you're going to get out of that. It knows your state of charge because it's planning your route for you, and you just follow the directions. Then when you get close to the charging station, it then diverts some more energy into the battery pack, heats the battery pack up, like starting like a half an hour before you get there, because you're talking about something that's like the equivalent of a bathtub or something like that,
yeah.
And you're going to warm that up 10 degrees. But you're not going to do that in 30 seconds, okay? So it starts to warm it up a half hour before you get there, and then you get the maximum charge. So some companies, like Tesla, their software is on a different level. Like it really is on a different level, and they'll have all that planned. My Hyundai, it has a winter mode that you're supposed to check, and that's going to divert more energy to the battery at the expense of range, keep the battery at a higher temperature and allow higher fast charging. But I only use AC charging. I just do the DC charging as an experiment. I don't really need that. So I'd just be kind of wasting energy keeping my battery hotter than it needs to be, so I don't click the box. And actually, when I do click the box, nothing much seems to happen anyway. So I don't even know if it works or if it's connected. Other people who are driving their Ioniq 5s longer distances and are using the DC chargers are mad at Hyundai for not having battery preconditioning as part of the software, when they do in some of the platform shared cars like the Kia. It does and the Hyundai doesn't, and they're pressing Hyundai to give them battery preconditioning as an over-the-air software update.
Right.
All right. So that is this slide. The end result is, it's really tough to know what you're going to get on a DC fast charger. It's just tough.
So Lawrence, That video that Lucid put out, the guy went to great lengths to talk about battery cooling.
Right.
So would you not just reduce the cooling to let the batteries warm up? Because the batteries create heat when they're generating electricity. So would it not be, you're not burning extra energy to warm battery packs up, you're reducing the cooling effect so that the battery can warm up?
Well, I can look at the battery, we'll look at the battery composition and how they make the packs. And they have their cells laid out in different modules and so on, and they have cooling channels and heating channels throughout the cells, trying to maximize the contact patch of the cell with either the cooling or the heating circuit to keep them in an optimum window. So the car driving along using 20 kilowatts to propel itself at 100 kilometers an hour, the batteries aren't getting hot. The discharge rate on the battery isn't hot, okay? So the battery isn't at the temperature. So it needs an extra boost to get that up. Now, if your car doesn't have battery preconditioning, you can put it in sport mode, give it the full beans, use all the power, and the batteries heat up. Then the batteries heat up and you go to charge it and you charge faster. So, and at these stations, you're paying by the minute, not the kilowatt. So you might actually take your EV and drive it like a maniac for 10 minutes and use
And
full
accomplish the
power,
same thing, yeah.
heat the battery pack up, get there to save money.
Seems like a reasonable response to me.
Does that make sense? All right, so, and then you might look at these stations and think, well, they all look the same to me, but these are 800 volt, and you'll get peak charging of 250 kilowatts if your car is 800 volt. And there's only a couple cars that are 800 volts. The Hyundai, the Lucid, the Porsche, the upcoming Porsches, etc. are 800. Everything else is 400. So if you take a 400 volt EV and you go to this, okay, well you're not getting. There might be cars that might touch 200, but you're not getting anywhere close to 200 kilowatts with your 400 volt car, no matter what one you're at, okay? If you have an 800 volt car and you match it to an 800 volt station, well then, and the conditions are aligned, then you can get really high sustained charge rates, okay? And then the little charge stations, well that's only 50 kilowatts. Okay, so we'll get into some range planning in a later slide. The Petro-Canada ones don't work that well. Like they just don't. Like they just don't. It's always frustrating. You try to connect and it never does, and it really is quite frustrating. And then, you know, they don't have any covers over them, so then it could be raining and you're out there with your car trying to get it to connect, working with your credit card, whatever. A Tesla, you just plug it in. It's plug and charge. It already knows your credit card number. It reads the car. It knows where to drive. It knows what to do. It works. They only have one car and one plug to deal with, so the software is a lot easier. These other stations, they have to read every single car from every different manufacturer. And when they rolled all these out, they couldn't get them from one supplier. And VW, who owns Electrify America, was under pressure to spend this $2 billion in infrastructure and build all these, but they couldn't just place an order for them, so they had to place an order to multiple companies to deal with 50 different platforms and different cars and credit cards and whatever, and make it all work. And, you know, they had lots of problems. Okay. So, we'll go here. Battery packs. So, in theory, you could have one massive battery, and electrons would go from the cathode to the anode and back again. Okay, but they don't do it that way. They put the batteries in cells, and then the cells in modules, and the modules in the packs. Okay. The way you organize and link together the cells is what gives you the voltage. So if you have a 1.5 liter, or sorry, 1.5 volt battery, okay, and you put two of them together and you align them in parallel, then you get 1.5 volts, okay? If you attach the negative to the positive and you put them in series, now you have 3 volts, okay? So you get to decide what voltage your battery pack is, and it could be any voltage. But the thing is, there's standards with voltage, and each piece of electrical equipment you have is going to work with a certain voltage. So there's conventions. If you want to go, you know, sell hair dryers, you're going to have to make it at 120 volts. If you make it at 10 volts, it won't work. Everything's 120 volts. So the same thing happens with the automobile industry. They just decided, for whatever reason, that 400 volts is the standard that they're using. Okay, so for just about everything out there, if you want to buy power electronics, you want to buy an inverter, you want to buy a motor, you want to buy this, you want to buy that, from any of the suppliers, they're all 400 volts, which is why everything is 400 volts. But there are some manufacturers that decide to arrange it in 800 volts, okay? But they had to be kind of clever and make their own power electronics and motors and everything else that were 800 volts so that they could use 800 volts. And there weren't many companies that could do that. Porsche was the first. And the reason that they were the first is because they developed it on the racetrack with their 919 hybrid. And the reason that they did that is because they needed to recapture a lot of energy really quickly through brake regeneration, and they needed to discharge a lot of energy really quickly. Okay, if they did that with less voltage, it would have more heat, and that's what these formulas are. Okay, so you have a Le Mans car. It's going 350 kilometers an hour, and it's a hybrid, and it has brake regeneration, and you're at the end of the Mulsanne Straight, and it's going from 350 kilometers an hour to, you know, 60 in like 5 seconds, something, whatever it is, okay? And you need to be able to take all that energy and put as much of it in the battery as you can, because then when you get through the kink or whatever, then you mat it, and you need all that power again, like instantly. So
And is that the same what's happening in the Formula One cars with the when they're doing regeneration for DRS?
yeah,
Right?
there's two kinds of regeneration. One's thermal from the turbocharger, the other one's under braking.
Yeah, so the battery I'm using DRS. So I know that because I was lucky enough to be at Monza this year. And when they come out after the start, they come into that first corner, they're going from 350 down to
Right.
50 kilometers an hour.
Now, you can-
The sound is just,
Yeah, now you can take all that energy,
yeah,
clamp your friction brake,
yeah,
and waste it to heat,
yeah.
or you can collect it and use it to accelerate again. All right, so the analogy that they had, that it was enough energy that needed to be recovered that would charge your smartphone in 1 second. So that's how much they needed, and to get that, they needed the high voltage, and that's where the 800 volt came from. Porsche, at least, that's why they put it in the Taycan, because they had their power electronics deal with 800 volts, and they could. Okay, so but there's not too many companies that are doing it. Mostly, it's the cost no object companies like Lucid and Porsche that are doing that. And okay, so then there's the voltage, and there's also the type of cell. There's all kinds of different cells. There's cylindrical cells, which look kind of like our regular batteries, but different sizes. But they're not all cylindrical cells. Some of the cells are in sheets, what they call them prismatic, and they can be in different shapes and different numbers and so on. It's up to the manufacturers how they want to structure these battery packs, and the battery packs need to be armored, because the thing about these things is if they catch fire, they don't stop. They'll burn for 5 days. From the manufacturers and the service facilities, you know, they give you, you know, in the event of a fire, their solution is to have a modified sea can and flood it with water, like
Sure.
drown the car up to, you know, 30 inches. Okay, that's the only way you can put it out. You just can't put it out. When Richard Hammond crashed that Rimac down the hill, it burned for 5 days. You just can't put it out. Okay, so the heating and cooling is really important. Now, with fewer pieces, it's a little bit cheaper to manufacture. And they're built in modules so that you can make one platform, one case, one heating and cooling system, but then you can have like a 60 and an 80 kilowatt or various levels.
And is that done if there becomes a problem with one of the modules that you can more easily swap it out?
Well, that depends. That depends on how it's made. Okay, so you have to connect all these things together, and you can do that in different ways. You could clamp them down with little screws and have bus bars and so on, and take you forever. Or you can kind of glue a conductive strip over them. The battery pack for the Tesla Roadster I'm dealing with is cylindrical cells with glued strips, and it's like packed full of epoxy. It's like, you can't do anything with it. It needs to be recycled. Some battery packs, you can't fix them. And the cheaper you make it, the less you can kind of go in and fix the cells. With like the Porsche battery pack, you can do an analysis and you can find the cell that's wrong and you can rebuild it and put a new cell in, and that's fine. Other manufacturers, you can't do that. So it's kind of good to know when you buy it. You find the prismatic cells, these rectangular sheets that are like larger, you find those with kind of the more affordable EVs, and you find the cylindrical cells with like cost no object. The Mars helicopter has cylindrical cells, the Lucid, the Rimac, the Tesla have cylindrical cells. Okay. And what they do, and you can heat and cool them in different ways. Like this is kind of an easy way to do it. You just get all these battery modules and you just put one big cooling plate in the middle of them. Other manufacturers weave cooling channels through the battery cells, so it's actually really quite intricate. Okay, and that's more money. The reason that you want all the smaller pieces is because the energy discharge can be faster, and the recharge and the charging can be faster. You can do that quicker when you have smaller cells, and you've got more potentially surface area with the cylindrical cells as well. Okay, so for whatever reason, all the high-end, the high-end manufacturers will use the cylindrical cells, but under whatever $80,000 SUVs, you mostly find packs like that. Okay. These cells, even if you have cylindrical cells, there's different chemistry. You can get cells that are optimized for power density. You can get cells that are maximized for storage density. You can tweak cells. So when you design the battery pack, you have to figure out what the objectives are. Do you want a discharge rate as high as possible? Do you want the longest life? Do you want the cheapest cost? Do you want this? Do you want that? And they all compete with one another, and they sort of figure out the optimum. Okay. So for each application, there's different selection of cells oriented in different ways at different voltages. Okay. Most manufacturers will just do one battery pack for all their cars. But, sometimes if there's a high performance variant, they'll have a different kind of battery pack. So most EVs will have a battery pack in the range of 60 to 100, 120 kilowatt hours. 60 kilowatt hours is a smaller battery pack. 100 is, 80 to 100 is for most cars. And, the trucks are usually 120. The Hummer is the biggest one at 225. Okay. This page is kind of, you're all technical there. It goes through the formula of watts equals volts times amps. This is Ohm's law, which is about resistance. You combine the two of them together, and what you find is that the power in kilowatts is equal to the amps squared times the resistance. Amps, I is amps, you know, it's the symbol for amps. And resistance, the resistance is basically equal to heat. The more resistance, the more heat. So what this says is that, sorry, you double your voltage, you half the amps. If you have half the amps, you quarter the heat. So going up in voltage makes a big difference with heat, and that's why you can have a high voltage car like a Taycan that can handle sustained voltage, high voltage for a long time, because there's less heat in the system.
And that would be the goal of the manufacturer, right, to reduce the amount of heat in the charge, so you could charge for at a high rate for a longer period of time.
And so the question is, if all you have to do to get high voltage is change the orientation of your battery cells, why doesn't everybody have 800 volts? So that probably will happen. All the EVs will come out, they'll just be 800 volts once everybody starts making 800 volt motors and so on. Okay, GM was kind of clever. They wanted to use 400 volt architecture, 400 volt parts, off the shelf parts for all their other stuff, but they have a 225 kilowatt hour battery in their Hummer, and how are you ever going to charge this thing at 100 kilowatts? And so what they did is, I don't know exactly how they do it, but they have their battery pack built in these modules that are 400 volts. When you charge, it changes the switching, so it's 800 volt when it charges, so it charges fast and it switches back to 400 volts when you drive. It's pretty clever. We think of power, you know, in horsepower. The torque times the revolutions. Kilowatts is the same thing. It's work. It's directly related to horsepower. It's a they both talk about the same thing. But if you frame everything in kilowatts, then everything becomes a lot easier than trying to convert horsepower. So for instance, you accept, you charge in kilowatts, you power the car, the motors, in kilowatts, you store the energy in kilowatt hours, you buy the energy in kilowatt hours. So you think, okay, well, I buy so many kilowatt hours from the electricity company, I put the kilowatts in the car at a certain rate, I put the kilowatts on a certain rate for a certain time, and then I put the kilowatt hours in the battery. Then I've got the kilowatts in the battery, kilowatt hours in the battery, and I expend kilowatts when I'm driving the car. So everything is going to be in kilowatts or kilowatt hours.
And now I know that my price per 134 horsepower.
Mm-hmm.
How much it cost me?
Right. Okay. So here's where I think it kind of gets interesting when you're planning your range. So you go to the, okay, so first of all, my car driving along the highway at 100 kilometers an hour uses 20 kilowatts. 20 kilowatts to move it through the air. Okay. Some of that's rolling friction, some of it's aerodynamic drag, some of it's heating the cabin, some of it's power electronics, some of it's losses. Add it all up together and it's 20 kilowatts. Okay. So what happens if I roll into a station and a charging station and I get 20 kilowatts? Okay, well, I drive for an hour I use 21, I drive for an hour at 100 kilometers an hour, I use 20 kilowatt hours. I pull into the charging station, it gives me 20 kilowatts. I stay in the charging station for an hour. I buy 20 kilowatt hours of electricity. I drive for an hour and I charge for an hour. It's a 1-to-1 ratio. So those are the, in my opinion, the two most important. Everybody talks about range, and range is important. I think range is important because it gives you flexibility. You can, this charging station doesn't work, I'll just go to the next charging station, okay? Or I don't have to charge. But when you try to go, 1,000 or 2,000 kilometers, what is going to matter is how fast you can accept your kilowatts from the charging station versus how many kilowatts your car is using when it drives. Okay. So if you focus on, and the ability of the car to accept charge varies widely, like very widely. Some cars only charge at 50 kilowatts. If you go buy a Chevrolet Bolt, it's maxed out at 55 kilowatts. That's the most it'll ever get. The Taycan's 270, okay? Well, they'll both use about 20 kilowatts to like push the air out of the way and get rid of the friction, but one can charge like 5 times faster, okay? So the ratio of, driving your Bolt might be, it might be 2 to 1. 2 hours to drive it, 1 hour to charge, okay? 33% of your time is gonna be charging. Well, Taycan, you might drive 5 hours for every 1 hour recharge, or 6 hours, or as we'll see, up to like 9 hours with some other cars. Okay, so all these cars now 400 or 500 horsepower. To just send the thing along the road, well, it might take 30 horsepower or something like that. Well, that's just 20 kilowatts, okay? So for steady state driving, you only need a fraction of the total horsepower of the car. You only need like 100 kilowatts will see you all the power you need to accelerate, merge with traffic, drive around. You simply just don't need any more. You don't need more than 100, but 100 will do it. So a typical car will use about 20, and breaking that down a little bit, it's almost a third between aerodynamic drag, rolling resistance, and then running the power electronics and the climate control. It's almost a third, but it's not a linear relationship, the same relationship between speed and friction, speed, and drag. You have one that's a constant, keeping the climate control, running the power electronics. You have one, the rolling friction, which is a function of basically the weight of the car and the resistance of the tires, that's more or less linear. And then you've got aerodynamic drag, which raises with the square of the speed, so it's exponential. Okay, so if you can look at an EV, you just look at it, and you can get a pretty good idea of what your consumption is going to be, and you know what the battery has for storage, so you can compute your own range by yourself, just looking at the car.
Yeah.
I mean, it actually turns out that that's more reliable than going to the EPA, because if you read the EPA and you get into it a little bit, you find out that all the EPA ratings are from the manufacturers who self-test the car on a rolling dynameter. And there's different tests. And as a manufacturer, you can choose a different way to record your mileage. And you pick which way you want to do it, then you send the results to the EPA, and you see, and they accept it or they don't accept it. And if you're too aggressive, you get in lots of trouble, so you don't want to do it. But it's more, it can be more a marketing or a business decision as to what range you're going to submit to the EPA that's published. Which is why, you know, a Tesla will never get its EPA range in any of the independent tests. And the Porsche, they're probably so terrified after Dieselgate that they just submitted the lowest number they could, and everybody went on about how inefficient the cars are. But they're not. What happens is the cars aren't that different. If you look at the way they're made, they all kind of look the same. You know, aerodynamics do vary, but not by that much, except for the trucks, which are differently, okay? And the frontal area, you know, the aerodynamics, or the CX and the CD are basically the shape of the car and then the frontal area of the car. Well, if you have a car that's going to fit 5 people, it's going to have a frontal area of kind of about the same as the next car, because it's got to fit people that are all about the same, right? And you know, they all have 4 tires, and there's quite a bit of difference between tires. If you have a sport tire that's really wide, or you have a rolling resistance tire, but each manufacturer has different variants with all kinds of different tires on it. So it really matters more what tires are on the car than what the published range is. Okay. All this talk about efficiency, they're all pretty efficient. It just, you know, there's a big variation in the EPA numbers, and not that big a variation in real life. Anyway, that said, if you take your rolling resistance, you know, it's going to be a function of weight and tire. EVs are all heavy. You know, but if you get one with a 120 kilowatt hour battery pack, well, that's going to be, you know, 500 pounds heavier than the one with the 80 kilowatt hour battery pack. Okay, so you know that. The tires need special attention because, you know, if you offer the off-road tires on your Rivian, you know, that could be 15% or something.
Yeah, the ones that can get the best range, whatever the stall
Yeah.
is.
Yeah, but if you try to go to Moab and scale your, you know, your rock like they do in the videos.
They offer a choice.
Yeah,
but they're very upfront about it.
But one tire is not going to do both things, right?
Right. So they're very upfront about it. That, you know, you choose the larger 22s, you know, that are a little more not MT, but you know, cross between MT AT. It's an automatic 15%.
Yeah. Okay. So it makes a big difference, and also, you know, for cars, you know, the sport tires are often wider as well, and that affects aerodynamics. So the compound will affect it, and also the width will affect it quite a bit. Okay, so that makes more difference. Your selection of the variant of the car you want, depending on the tire, makes a bigger difference in efficiency than the kind of car you have in a lot of cases. Okay, so that's rolling friction, and it's pretty linear. You know, the faster you go, you know, the more resistance there is. Okay. Aerodynamics is, you know, just isn't like that. You know, so if you have a super aerodynamic car like your Mercedes EQS or the Lucid, and you have a CD down to 0.2 or something like that, it's pretty slippery. This curve will look a little bit different, and the difference between 110 or 100 and 110 or 120 and 130 will still be there, but it won't be as significant. If you try to take your Hummer barn door and drive it at 140, it's going to be an astonishing amount of power that it's going to take. So the efficiency of the car, and particularly the aerodynamic drag, will vary with what kind of car it is and what kind of equipment is on it. You want to be conscious of that. If you're looking to maximize your range on the highway, you're going to need to slow down if your car isn't particularly aerodynamically efficient. So that's what that is. And the EVs don't like cold weather at all. Like, they just don't like it. You'll see half the range in really cold weather.
Define really cold.
Minus 20.
Okay.
Now,
Is it logarithmic, like minus 20 and then minus 40? It's
well, there's the graph, and this is sorry, I couldn't get one in Celsius. And -4 is about minus 20.
yeah,
Something like that.
45, 50%. Wow.
So you can see what happens, and they also don't like being too hot either.
Right.
Okay. Now, what happens is having the EV start off in your garage and having the battery at room temperature makes a pretty big difference to your cold weather range from getting in it, and the whole battery is like, you know, minus 30 or whatever. With the Hyundai, what I see is the best consumptions like 16 and a half. Average consumption in the winter goes to 25. But if I started from cold and it's a cold day, the first 30 kilometers are like, you know, 35 kilowatt hours. Like it almost doubles.
Wow.
Now you drive it for a while and the battery warms up, and the less battery power goes to warm the battery, and then your consumption starts to fall, and you know, you get in the low 20s after a while.
So they're going to come up with the preconditioner / battery heater, the aftermarket battery heater?
Well, you know, when you plug in, of course, you have the ability to preheat your battery, and
Yeah.
we do that with the car, because on just about every EV,
Yeah.
you can set the climate control because it's you know,
Yeah.
attached to the house, preheat or pre-cool the car before you get in, and that also has an effect on the battery too. Okay, but for sure, if you want to take a worst case scenario, half your summer range. I just recalled something that I should have mentioned back here.
So sweet.
Go back here for a second. I was struggling to try to come up with a range of time estimates, how to interpret these charging curves, how to come up with one equation which was reasonably accurate. And I fooled around with it for a while, and I watched like every YouTube video on range, and I checked all the math, and what I came up with was that in perfect conditions, if you take 20 to 80, and you take your maximum, and you half it for an average, you're going to be pretty close to what you're going to get. Now this is exceptional, but for most cars, if you know your car charges at 200 kilowatts maximum, in perfect conditions, from 20 to 80, if you half that amount, that's probably a decent number to at least start with when calculating time and distance with EV. And I did that at the end, which I'll show you. Okay, so we went through that. The consumption figures are really confusing with EVs. You know, some say, well, it gets so many watts per mile, so many watts per kilometer, so many kilowatt hours per 100 kilometers. Oh, this is so many mile per gallon E's.
Mm-hmm.
And then each article you read has picked a different number and a different set of units. And it's like, well, this one says I get so many watts per mile, and this one says I get so many miles per gallon E, and it's like, well, what is all this?
Mm-hmm.
Okay. So a mile per gallon E is, I think, particularly kind of useless. What they did is they just said, well, how much energy is in a US gallon of gas? Okay, they came up with it so many joules, and that's 33.7 kilowatt hours. So a mile per gallon E is how far is your EV going to go with 33.7 kilowatt hours of electricity, okay? And it turns out that most of them go around 100. It also turns out that 100 is around 20 kilowatt hours per 100 kilometers. But 20 kilowatt hours per 100 kilometers for a car is just about what they all wind up with, plus or minus a few, okay?
Yeah.
And your mile per gallon E always is going to run around 100 mile per gallon E. Okay, but if you see that, I don't advise paying much of attention. I think you should always stick in kilowatt hours, kilowatts, kilowatt hours per 100 kilometers, and everything just sort of makes sense.
Right.
But what that is 33, the distance your EV will go using 33.7 kilowatt hours, okay?
Yep.
the reason that you can get like 2 cars and you have a internal combustion car that's rated at 30 miles per gallon, and the electric version of it is 100 mile per gallon E, is because the same amount of energy, the electric car will go like 3 or 4 times further.
Right.
And the reason that is, it just doesn't take the gas and create a lot of heat.
Yeah.
Okay, so that's what that is. I'm paying, I think, 12 or 13 cents a kilowatt hour at home. You know, my car, it's got 5,000 kilometers on it now, and the average summer and winter is 20. It's like right on 20. You know, going 100 kilometers is the 20 kilowatt hours times the 13 cents, or you know, whatever that is, 250 or whatever it is, 260. You know, my Range Rover, all my other cars get like 15 liters per 100 kilometers. And
Yeah.
the liters like
You make a smart choice.
170. So going to Canmore is $50 in any of my other cars, and it's like, you know, $5
In the EV.
in that thing. Okay. So there's companies that, or there's, you know, different stats and so on that show the saving, you know, but it's, you know, you're generally spend, you know, $3,000, $4,000, $5,000 a year on gasoline on a combustion car. For most people driving 20 or 25,000 kilometers, EV is going to be like a tenth of that, and then the servicing on it's almost non-existent. You never use the brakes. You just don't. It's all regenerative. If there's an accident or you're trying to avoid an accident, your brakes last the life of the car. There's no cooling to change. Yeah, maybe you should do your brake fluid. Maybe I'll do it every 5 years. I don't even think I'll go to the dealer. Most of the updates are online. I don't know why I would go to the dealer. So it's not gonna do it. So, you know, you take a 10-year life and, you know, $3,000-4,000 a year in saving, and they come up with, you know, a national average in Canada, depending on where you live, of like 25 grand over 10 years. All EVs are, and we'll see this in some other slides, kind of designed the same. And if you look at, you know, every EV on sale today, and you peel off the body and the interior, and you look at it, well, they kind of look all the same. Okay. The platforms allow for different widths, different tracks, different heights, different gear ratios, different size motors, different size inverters, and different size batteries. So it's kind of like you create the platform, and then you have, you know, a 1-motor, 2-wheel drive, either front or rear version, and you might have 100 kilowatt, 125 kilowatt, and 150 kilowatt motor, and you might have a version that has 2 motors and is all-wheel drive, and you put a motor in that, and you can decide the size of the motor, it goes front or back. Then you have a couple of different battery sizes, okay? With the performance variant, you might have larger inverters, so there's no bottleneck when you're dispensing the power. And you mix and match these components, and the components all come from not that many companies, and most of them are in China. So it doesn't matter if you're VW or whatever company, you buy the same motor and the same inverter and the same battery from the same suppliers. So there's not that much difference in most of the EVs. I mean, yeah, some are 800 volt uniquely, some are 800 volt. Really not much. I mean, there's difference in cells, there's some differences, but they're a whole lot more the same than they are different. And there's nothing like the differentiation of a combustion engine car, where you've got the characteristics of the motor and the different gearbox and all kinds of things that make one combustion car a lot different than the next. The EV cars, they mostly all just drive the same. So They don't make particularly wonderful lightweight sports cars. There's things they don't do well.
They need to.
But most of them are fairly generic. Okay, not only that, consumer electronics companies can build them too. So this is up there, there's a whole skateboard that's being marketed by Cattle. Cattle is has the largest market share, largest producer of lithium-ion batteries, 30% of the market. You know, it's a massive company, so instead of just selling batteries, they're going, okay, we'll make the whole skateboard, and you know, and then they sell it. So VinFast, you know, the Vietnamese company, they're like, okay, we'll buy the skateboard from you, we'll put our body on it, and that'll be that. Okay. This one here is from Foxconn. Now, Foxconn sales in 2022 were $219 billion. They make all the iPads and iPhones and most of the gaming consoles. And they're getting in the EV business, and they're marketing this to whoever wants to buy it. There's a company called Lordstown in the US that makes trucks. They ran into all kinds of problems. They bought a factory from GM, but they ran into financial trouble and all kinds of trouble. Foxconn bought the factory, and they're making their pickup truck. Same people that make your iPhone are going to be making pickup trucks. Also, Fisker, their first car, they just subcontracted the whole thing to Magna. Magna's building the car. They build lots of cars. But for their city car, they're also getting Foxconn to build it in the US. And more companies are building their batteries and EVs in the US to take advantage of the tax structure and incentive structure that Biden put in. So if there were companies that wanted, I think, $7,500 credit for buying an EV, the batteries and the vehicles have to be made in the US. So now, otherwise they don't get it. Like for instance, the Hyundai doesn't get the credit anymore in the US. Okay, so there's a lot of companies now that are mostly buying old GM big three factories, converting them, making the EVs there, and then selling them. So anybody can do this now. For VinFast, the short on that is it was a Vietnamese guy who moves to Ukraine, comes up with some like instant noodles, builds up a business of instant noodles, sells it to Nestle for $150 million, moves back to Vietnam, starts buying real estate, buys real estate, then starts building homes and theme parks and an AI company, and is like, I think 2% of Vietnam's GDP. Some crazy company that's like, and 30% of the stock market or something, market capitalization of the stock market. This guy decides he's going to build cars. So let's build a car, hires Pininfarina to design it, hires Siemens to build a factory on swampland, okay? Hires Magna to tell them how to build it, licenses the technology from BMW. Within 1 year, they've got a prototype at the Paris Auto Show.
Yeah.
2 years, they delivered their first car. Now they're just investing $4 billion in the US to build their cars there. And it's like, wow, they're not fooling around.
Yeah, they're gonna do it.
And they're coming to Canada. They have a unique battery lease program, which doesn't make any sense to me. Anyways,
I didn't understand it when I was reading on it, the lease program. I don't.
well, you pay 10 grand less for the car.
Yeah.
You know, so it's 60 grand instead of 70 grand, and now you pay 260 bucks a month to lease the battery.
Right.
So forever, and that lease contract goes with the car. The only problem with that is $250 a month is $3,000 a year, and the battery's going to last at least 10 years, and you're going to pay $30,000 for battery, and batteries have come down in
25,000
price, and you're only saving 10 grand. So it just doesn't make a lot of sense. But the cost of a battery now is 135 US per kilowatt hour. So then 100 kilowatt hour battery pack would be about 13,500 US. That's not the price at the parts department of your dealership, but that's the cost of manufacture. Okay. We talked about the 3 motors and the 4 motors and the torque vectoring, and just how flexible these platforms are. We'll see that later. Okay, so you're going shopping for an EV, and so like what are the key measures? What are the key capacities and units and so forth that you need to pay attention to? So they can be 2-wheel drive or 4-wheel drive. The version of the car that you can have can be front-wheel drive or rear-wheel drive. Okay. It can be 2-motor, 3-motor, or 4-motor. Okay. And within each different model, you can have versions of each. Some cars you can have a front-wheel drive, a rear-wheel drive, or a 4-wheel drive. I've never seen that before. Usually there's a rear-wheel drive version and there's make an all-wheel drive version, or a front-wheel drive and they make it all. You can actually have the front, rear, or both, because it's just as easy to make. Here's something interesting with when you have all-wheel drive, is it always all-wheel drive? And what triggers the all-wheel drive? I had the Hyundai in eco mode, which is the mode I always have it in, and didn't think anything of it. I just figured that it would be in 4-wheel drive or go in 4-wheel drive when you needed it to. Like just about any car, as soon as you need 4-wheel drive, it'll sense the slip and put the power into all the wheels or whatever. And Sarah was like, oh, it was really slippery. I could barely get up that hill, my wife Sarah. I was like, well, that's kind of odd. Like it should have been able to do that. I had brand new winter tires. And I thought, I wonder if it switches from rear-wheel drive to 4-wheel drive. And it doesn't in the eco mode. There's nothing you can do to it in eco to make it switch into all-wheel drive. You have to hit the button on the steering wheel to put it in normal to get 4-wheel drive. And also with that car, there was like any EV, it's extremely fast, 0 to 100 in under 5 seconds, but not in eco mode, because in eco mode it just runs on one axle, and it's got, maybe 200 horsepower, something like that, and that's all it uses. When I wanted to pass somebody and I matted it in eco, I just figured it would kick in and give me the power, but it didn't. I matted it, it didn't do anything. Well, I thought that was kind of odd. In a Taycan and some of the other Porsches, there's an indent in the throttle pedal. If you go past the indent, it'll turn on the engine or give you full power. But in that car, if you don't change it on the steering wheel, you're not getting the power and you're not getting 4-wheel drive. Oh, kind of interesting.
Eco mode is eco mode.
Pardon me?
Eco mode is eco
mode.
So.
Even if you want. How large is the battery pack? Okay, and then we have the total battery capacity and the usable battery capacity. And the batteries often don't like to go to 100%, and they don't like to go to 0. They especially don't like to go to 0 and sit there. One of our Tesla Roadsters that we're dealing with, the guy did that. The battery is junk. You can't even buy a new battery. The car's been out of commission for more than a year. A new battery's $30,000 US, and
for the original battery, not for increased kilowatt capacity, right? That's the
well, it does have a little bit. The new battery pack has a little bit more power density. It's 10 years newer. Okay. But try to get it. And this battery pack, there's nothing you can do. It's junk. It's sat with 0 charge. It's bricked. Okay. And there's no provision in the car in that 2011 Tesla Roadster to protect the battery. There's lots of warnings in the owner's manual not to do that, but he didn't look at the manual, and the car's done. Yeah. And that happens to every Tesla Roadster almost, which means that there's probably a third of them that just don't work, and there's no support, and anybody who made power electronics for that car is now out of business or doing something else. There's a whole little cottage industry of owners who are you know, who
Try to
are,
build their own battery pack.
yeah, they're trying to keep these things on the road. Okay, anyway, the manufacturer will set these parameters with the battery as to how low it can go and how much it can charge, okay? And if a manufacturer taking a conservative stance, like Porsche did when they came out with their first car, they're like 93 kilowatt hours total, but only 83 usable, 10 kilowatt hours in that you couldn't use, okay? Other cars like the Tesla will kind of let you use almost everything. Although each EV lets you set it, you know, and they'll recommend only charge to 80, only charge to 90, etc. So you can set those parameters in the car. But if somebody says, oh, our car has a 100 kilowatt hour battery, you'd want to know whether that is the total battery storage or the usable.
So Apple now does that with their new devices. So the new iPhones, new iPads, you have when it's charging, will only actually charge it up to about 83 to 90% and prolong the life of the battery.
Yeah. What is the estimated consumption, and try to get it in kilowatt hours. At the end of this, I took all the numbers for every EV sold in Canada and dumped it into one massive spreadsheet, and it's all right there. So I'll give that to you guys. But you want to get an idea of what the consumption is per 100 kilometers. If you decide you want to look at a Rivian, go to YouTube and do Rivian range test. There's 10 videos that come up with people doing that and measuring all the consumption.
There's an aftermarket forum of Rivian owners and people on the waiting list. And
So you can.
everybody loves to post.
I wouldn't go to the EPA or Transport Canada. I just wouldn't. It's not a reliable source of information. Okay. We went through the wheel options and the tire options, which have a fairly, you know, up to 15% of the range, depending on which rim and tire. Okay. I think really the key one for having an EV in Calgary is, you know, are you using this for long distance travel? In which case you're relying on the DC charge network and the capacity of your car to take like a DC charge, the stability of the network, and so on. And Tesla's miles ahead of anybody else on that. So if you want to go from Calgary to the interior of BC regularly, you want a Tesla. Is much easier, much more reliable. The range planner is better. The stations are better serviced, usually working. You don't have to fool around with apps or anything. You just plug your car in. The charge rate's more predictable. It's more robust. Tesla had like a 5-year head start on that.
Well, all due respect and apologies to Teslas, they're ugly.
But if you wanted to get an electric car and you wanted to drive it year round and you needed to count on the DC fast chargers and you needed to cover long distances in Alberta and BC, you'll have a hell of a lot easier time getting a Tesla that gets a Model 3 that uses 18 or 19 kilowatt hours per 100 kilometers, charges at an average of at least 100 kilowatts, and has a well-developed charging network where you pull in, it's got Wi-Fi, you pull in, you pull up your movie, you do your things. It charges, you almost don't want to leave because you've gotten comfortable, okay? What I'm doing with an electric car, well, I'm just not, it's not going to pull my camper. It's for my wife to drive around the city and do the errands. The only time I ever use a DC fast charger is just to test it. And, you know, there's only like 2 times my car's ever been below 50% state of charge. Like we just get in the car, we put 50 kilometers on it, 60 kilometers on it, use, you know, whatever, 10 kilowatt hours of electricity, plug it in for an hour, don't think about it, and that's it. So for us, I don't really care. But if I was on the highway all the time, I would buy a Model 3. Even though, you know, really, are you going to use it local and charge from home, or do you need a DC fast charger? If you need the DC fast charger network, well then you got to ask some questions, take a deeper dive into it with charge rates and where these chargers are. And then it's not always obvious what charge stations are running, which ones work, how and what kilowatt they dispense. Okay, so that is not actually, the charge apps that I've looked at don't give really complete information. And you know, if you roll up to a Petro-Canada, you're not going to know whether it's 400 or 800 volt or whatever, right? So there's a fair amount of study that goes into that to make sure you're doing the right thing. The AC, how much AC can the car take? Well, there's some little EVs that only take like 3.6 kilowatts. Like I think the first Chevy Spark and something like that. You know, I think some older EVs are like 6 kilowatts, which is probably the bare minimum. There's a lot of 7.2 kilowatts for EVs that are a few years old. 11 kilowatts now seems to be the norm that most cars take. Okay, but not everyone. So, and then not every version of every car. You might see that your whatever it is, Volkswagen or ID.4 takes this amount of kilowatts, but it's only for the top version, the base version, or the big battery. You get the little battery and you think you can charge at this. Oh no, you don't get that. Or like the Porsche Taycan, you don't tick the right options.
All about the options.
So you need to really nail down not just what manufacturer and car you have, but what variant and option package. And well, let's face it, the sales guy's not going to be able to tell you that. So you got to really figure that out. Sorry. And okay, what's the maximum DC charge rate? Okay. Can the battery be preconditioned? Again, this is only relevant if you're driving on the highway. Can individual cells in the battery be replaced when it comes time? And can you rebuild that pack, or do you just have to recycle it? Can the EV accept over-the-air updates, or do you have to go to the dealer every time they want to change something?
Jumping back to recycled batteries, how are they recyclable?
Yeah, you take the battery pack and you put it in a giant shredder, and it cuts the thing up into tiny little pieces, and then through a series of processes, magnets, putting it in various chemical baths, etc., you filter out the metallic particles and then throw out what you don't need.
And
So
they take all those rare earth minerals in there, and they'll recycle it into something else, or it's almost kind of like the same thing they do with lead acid batteries, right?
So the industry's there now, because originally.
Well, it is for lead acid. I don't know about.
No, it's there. They're doing
Is
it.
it? Okay, because when the Prius first came out, nobody knew how long the batteries would last and what you would do with the batteries when they died. So that's obviously.
Yeah, no, it seems that that's what you do, is you just grind it all up and then separate the metals and seems to be, I'm still energy intensive to do that, but
They're not putting them in a landfill though, basically.
no. Now, if the EV's from a new startup and you live in Alberta, well, what's the network of service providers? Where are they going to fix this car? Are they going to come to you? I mean, I look at the Rivian website, and sometimes I go look at the job postings.
Yeah.
And there'll be field technicians. You go to this guy's, go to the customer's house and fix their car. And so they'll have like a network of people that are managing a certain territory. Are they owning those facilities themselves, or are they just kind of making a deal with a dealer group somewhere to fix the cars for them?
Yeah, and in Calgary, Rivian has purchased the land and the building, and they're building the service center in Calgary.
Okay.
That's the blueprint.
I thought you said they didn't need service.
Well, they'll need a place to drop the cars. There's always preparation.
Yeah.
But that was a decision.
And
that was a decision point for me.
if you go to Tesla,
yeah.
their service is jam-packed. And it's true that they don't need any servicing, but after 5 or 10 years, the wiper motors still break and the seat heater doesn't work. And
Especially the Tesla.
So the supply chain's a disaster. You can buy, I think, a Ford Mach-E. You can buy a Tesla, and it'll come in 3 or 4 months. The Hyundai, forget it. It's 2 years away. The Kia EV6, forget it.
Well, they are each one.
The Audis, I think, are available. VW, they only started selling in Alberta because they were just in Quebec.
I know it is a EV bonus that you can take.
Yeah.
Mm-hmm.
So, you know, probably half the EVs that you see advertised, you just can't buy them, you know.
That's not a bad marketing strategy.
Well, it can be frustrating if you want a car. And then, if you do buy it, well, I mean, the Ford got into lots of troubles because they, you know,
Yeah,
you watch the, you know, the launch with the CEO, and then you think, okay, well, I'll put my name down, I'll get a Lightning. Put your name down, and you select a dealer that's near you, then the dealer says, oh, well, you know, we have so many of these orders for the Lightning, if you want yours, pay us 20 grand more. It's like, well, I bought it, I didn't even go to the dealer.
And that's the quickest way to never get me to buy a car from you ever. I will, even if you make the most beautiful supercar in the world,
Yeah.
and you have tried to screw me or other people like that, I will cut my nose off to spite my
Yeah, and
nothing to do with you.
And the CEO is like, listen, to the dealers, you do that 3 times, you're taking away your franchise.
Right, and that's what I'm saying. I think there's a reckoning coming.
Yeah.
Absolutely, because you know, it's a disaster trying to order an EV. That's all I can say about that. All right, so this we can go through pretty quickly, and the objective of these slides is to show you what the platform looks like and what all the cars look like.
They look pretty normal.
And you know, you can have one platform and it can spin off an ID4 or you know an id.buzz, and you know, completely different machines, yet they all look like that underneath. This is the Porsche, this is the Taycan, and it's unique because it has a 2-speed rear gearbox.
Mm-hmm.
And electric motors, all electric motors have a gearbox. It's just 1 speed. It needs to be slowed down 7 or 8 or 9 to 1. Okay, so so the Taycan has 1 speed that's good for 0 to 260 kilometers an hour. All right, the full speed range. But it has another speed that's only good to 60 or 100 kilometers an hour, just to get to 100 kilometers an hour a little bit faster. So they went through all the complexity to have a 2-speed gearbox just to have a low gear.
See, they know some of their customers.
So, but you can't put the power down anyway. So it's just needless, in my opinion, needlessly complex. Then they were in a race with Tesla to have the fastest EV, and they wanted to publish the fastest 0 to 100 number, and so they did it. They made this gearbox, and then Tesla thought, well,
We'll just tweak the software.
no. What they did is they got their motor to rev higher. So the normal electric motors that everybody was using were limited to about 15,000 RPM. And so Tesla came out with an engine or motor that goes to like 20,000 RPM. So did Rimac. I think in parallel, separately.
Right.
They both decided, and Rimac was looking at multi-stage gearboxes as well with a cost no object car. And they redid everything like 3 times and came to the conclusion that increasing the rev range or the RPM range of the electric motor was more effective. So they came out with a plaid and to get the speed range up to 200 miles an hour, which I don't think it can get yet because there's no tire that can do that yet. But they made a carbon, like a carbon fiber winding or some sort of really complex technical solution.
That doesn't shred the tire.
Well, this is for the motor, to get the motor to go to 22,000 RPM. And so when you have the motor that has an effective range of like whatever 0 to 22,000, they didn't need the gearbox, and they came out with a plaid and it was destroyed everything anyway. So they gave up. So this isn't going anywhere.
Does it make it different to drive, or is it?
No, you heard a bit of a jolt when it changed gear,
Right.
but it was like, well, like.
So it's not anything tactile.
It's not the V8.
It didn't make it. They kind of did it. I don't know why they did it. It didn't make a lot of sense to me, and it didn't make that much difference. And I think you really had to floor it to actually get it to go in the lower gear anyway, which It has enough power, believe me. Anyway, so this is kind of dead, but they made the Audi e-tron GT and the Taycan using that platform.
That e-tron GT is a nice.
It's a nice looking car, yeah. Now you can also see that the way they stack these modules, they stack them too high in the back and then none in this cavity, and that's of course where your feet go in the back. So they carved out a little bit of space in the back by doing it. Lucid did that
So
too.
Fred is not an option.
Pardon me?
The Fred is not an option.
This is the replacement for the expensive portion Audi. It's called the PPE, or Premium Platform Electric, and it's got a bigger battery power, and you can just see the packaging is just a little bit better on it, because it doesn't have, well, the gearbox is in the rear actually, but somehow they just managed the packaging a little bit better, and this will form the new Audi A6, and there's an electric Macan coming.
I would expect that for those premium brands, those, you know, sort of halo EV concept cars, are they paying just as much attention to the handling and performance characteristics with the EVs as they do with the ICE?
Yeah, so, okay, so what do you, I mean, you can start out with, you know, a platform that looks like this. You can make a cheap version with one motor. That motor can be pretty small. You can have a small battery in it, which is cheaper. You can sell it for 50 grand. You make it with two motors. You increase the battery to 80 kilowatts or whatever, and now you have something that you can sell for $60,000, $70,000, $80,000. You can increase the size of the motors and the inverters, and get it up to $70,000 or $80,000. Okay, you can bump it up from 80 to 100 kilowatts. You can bump the power from 200 kilowatts to 300 to 400 to 500 kilowatts, like this one. You can add air suspension now, the air struts instead of the conventional shocks. Okay, so that's going to do it. You can add rear wheel steering. So you can. I'm sure this has it. And now you've got something with 100 kilowatt hour battery or 120 with air suspension, with rear wheel steering. Okay, so now you can make this the basis of like a Bentley or Lamborghini or something. You can put two 250 kilowatt motors in there. That's 800 horsepower or something like that. Okay, you can even have ultra high horsepower versions of it. So that's kind of what you can do. You can go one step more than that, and you can put individual motors in the rear. Now you can get torque vectoring, so now your big heavy machine can handle better. And you could also put two motors in the front. So you could take this, quad motor, four big electric motors, big inverters, air suspension, and now you've got a car that you can sell for $200,000 or $300,000.
So the weight 6,000 pounds.
It weighs 6,000 pounds.
What?
There's the Volvo version, there's the Hyundai version. Here's all the cars that have the e-gmp. They're all totally different cars. Hyundai's made each one look, they're all called the Ioniq. They all have lots of pixels on them. They're kind of channeling Minecraft or the 80s or something like that. And they're all look totally different. Other manufacturers, well, they're hard to tell these apart. The Polestar looks almost,
Like
except
a
for the
Volvo.
grill and a few other things, it almost looks like the same car. The Volvo EX90 deserves special comment. It's not on this platform, and this big box up there is LiDAR. So that's the first. I think the Lucid has LiDAR as well, but that I think shows 270 degrees, if I got that right. And then it uses mirrors with a laser, and it maps out this light point cloud and can get the distance for each of these thousands or millions of points of light, map out everything, so it gives precise distances. And for autonomous driving, some debate about it. Musk thinks that cameras are enough, but cameras can get
It's only, it's basically your phone, your new iPad, your new phone, do LiDAR. to map rooms and stuff. It's basically the same technology, stuff's good.
But now it's the first kind of mass-produced car that has LiDAR. So that really is a significant advance. Okay, and the next slide. So there's a Rivian. We have battery pack detail, and those are not cylindrical cells. Those are battery sheets which are laid in. Not that it really matters, but the Rivian's interesting because they combine a kind of a traditional truck frame with the battery pack. Battery sizes from 105 to 180 kilowatt hours. DC fast charge to 200, so good. This is a real monster. This is the GM Hummer, and they've got their scalable, what they call the Ultium battery system, and they can not only stack different modules, they can stack them too high. So the Hummer gets this massive 3-motor battery pack, 3 motors in this vehicle, and the batteries are stacked too high with the cells, and they're individual sheets, and it's like 225 kilowatt hours. And it needs it because it's over 9,000 pounds.
You're gonna have to go through the weigh scale.
I think that
Yeah, right.
in Canada, there's a luxury, 20% luxury tax over 100 grand. I think that I read somewhere that the Hummer doesn't have the luxury tax because it's so heavy it's classified as a commercial vehicle.
Oh,
Okay, so there's the Lucid. Now the Lucid is the range champion because it's a big battery, 118 kilowatt hours. It is very slippery with one of the lowest CDs of 0.2. It's high voltage, 800 volt architecture, and they've designed all their own power electronics, so it's all in-house. And Lucid supplies the battery pack to the Formula E race series. The CEO of Lucid is ex-Tesla and ex-Lotus. And they're expensive. They have 2-motor and 3-motor, but you can get a Lucid up to 800 kilometers.
wow.
And it's really fast charging. So that's the champion for point-to-point driving at the moment. It's extremely expensive, and they're coming out with an SUV. Here's your Rimac. Rimats, I think is how you say it. So we have the twin front motors with the inverters. There's a cooling plate. There's an upper and a lower portion, and a cooling plate in the middle. And these junctions here accept the coolant in and out. We've got the larger inverter, again, 2 different pieces, a big cooling plate in the middle. We have 2 big motors outboard. That's the gearbox, a single speed gearbox to the rear. That motor is 500 kilowatts, 700 horsepower per side. And the front is 200 kilowatts per side, and it's 1,400 kilowatts, and that's like 1,900 horsepower with 120 kilowatt hour battery power.
And it's beautiful.
And that's it. Now, I think the Pininfarina is a little bit pretty.
Well, that's the one. That's the one that they tested on Top Gear. Is the Pininfarina Battista.
Okay, so Rimac makes all of the chassis, and they make their own car called the Navera, and then they give that chassis to Pininfarina in Italy. They do their own tweaking and put on this body and make a Pininfarina Battista. Rimac, it's an amazing story. The guy started from nothing in Croatia. He had a 3 Series BMW, he electric motor in it, started drifting it, started building components, then decided he wanted to build a hypercar in Croatia that doesn't have an automobile. Anybody who ever talked to him said he was nuts and it was impossible. Somehow he did it. He funded it by building components for other manufacturers, and then Porsche bought a stake, then Hyundai bought a stake. He went from just scraping by to to now he's up to 1,500 employees. And then Porsche increased their stake and merged. It was a complex structure, but now Porsche, Audi, VW have some shared ownership with Rimac, and Matej Rimac, who's now the chairman of Bugatti, the CEO of Bugatti, as well as Rimac. And now they make electrical components for everybody. I think the way it started is that I think Porsche sent them a car, and he said, I can do this and I can do that, and they said, okay, well, why don't you take one of our hybrids, Cayenne hybrids, I think, and see what you can do with
Oh,
it.
Cayenne.
And they tweaked it, did their things, and gave it back to the Germans, and it was like way better. It's like, okay, well, that's what he's doing. And Rimac has cylindrical batteries. He's got a great video series on what it takes to actually make a car, and it's extraordinary. I went back to some of my, well, I guess went back to some news articles when he came out with his first Concept 1, and maybe that was, I don't know, 2015, 2016.
Same time as Koenigsegg, wasn't it?
Well, Koenigsegg's been around for a while.
But I mean, in terms of when you started to really hear about those hypercars.
Well, I got a ride in a Koenigsegg. Oh, I don't know, 10 years ago at least.
Wow.
10 years ago. Anyway, it's an amazing story and a very engaging guy. He's only like early 30s, I think. Okay, and then,
By the way,
all right, I took every EV on sale in Canada, put every number into it, base price, if there's a rebate or not, total power, drive type, classified it, picked out the platform. These platforms have names, e-gmp, G1. Usable battery, voltage, number of motors, AC and DC charge rate, consumption. I got some of this I've estimated. It's mostly checked on real range results from various sources. I've then, using the formula I gave you guys earlier, where I take the maximum power, divide it by half, and then calculate how long it takes to put in 60% of the battery, I spit out a 20 to 80 minute charge time estimate in minutes. So you roll in with 20, charge it till 80. That's a certain amount of kilowatt hours, depending how big your battery is. Take the peak charge, half it for an average, and spit out the number. I put a range number, which is using a bunch of different sources and estimating some, but then checking all of the range estimates against all the guys that have done it on YouTube and so on, and made sure that everything makes sense. I've taken the DC charge rate and the consumption and spit out a ratio of how many hours driving to how many hours charging, what that ratio is. So there's some cars, you know, the 800 volt cars that are expensive, you can drive it for 9 hours and charge it for 1 hour. There's some cars like you know, Chevy Bolt or a little Fiat or something like that, you know, or the Jaguar's not very good. You know, for every 1 hour, for every 1.8 hours of driving, you charge it for 1 hour, okay? And then what I did is I took a baseline of driving to Vancouver, 1,000 kilometers at 100 kilometers an hour. That's 10 hours if you didn't stop, okay? So then I took the consumption and the DC charge time assuming that you found the stations and charged from 20 to 80, how many hours it would take you. So 11.1 represents 1.1 hour of charging time plus the 10 hours of driving 100 kilometers an hour. So if you spend 150 or 200,000 bucks on the fancy EV, you know, you can get to Vancouver just stopping 1,000 kilometers, an extra hour and 10 minutes, okay? Not much more than a combustion engine car, if you're the type of person that actually stops for lunch and doesn't just go there as fast as you can, okay? If you get something that is not particularly efficient and doesn't have a fast DC charge rate, you know, you're in the 15s and 16s, and
There's really not a lot of variation between, like, overall.
yeah.
They're pretty bunched in, most of them are bunched in.
But if you got a Nissan Leaf
Yeah.
that charges with Chatamo, that has a DC charge rate of, right, that's it right there. So your DC charge rate's only 46 kilowatts,
Yeah.
and your consumption's okay, but it doesn't make up for that. You know, you're getting there 6 hours after the e-tron. But to Simon's point, most of them are all in the
Yeah.
same range.
Yeah.
Like if you take take all the cars that start with an 11, well, that's like probably 60 or 70% of all the cars that you can get.
Yeah.
And they might have different ranges, but for your actual progress, the range doesn't really matter that much. It matters for flexibility. It matters if there's a forest fire on the way. It matters if one charge station is out of commission. It matters for the flexibility in planning your route. But the factor which will influence how soon you're going to get there are A, the consumption of your car, and how quickly the energy is discharged versus how quickly the energy can be charged. And if you take those two things, that is going to determine how quickly you're going to get somewhere. And if you're in a $2.5 million Rimac,
It's the same.
it's not going to be any different than,
Tesla or
you know, my
Mustang.
Hyundai Ioniq 5. It's the same number. So what you get out of this is, well, you want your DC charge rate, you know, ideally to be 150
Right.
or more. Okay, you want your AC charge rate to be 11. Okay, you want your maximum range, you know, probably to be at least 400. Okay, so if you get those, you're probably going to be fine. Because in the winter, the worst case might be 200 kilometers, and maybe on a busy day you might drive 100 kilometers. I mean, really digesting all of this, and then going and looking at the platforms and how similar the platforms are, it's really maybe not that surprising that the numbers aren't that different as well. And they don't drive that much different, and there's not that much to differentiate the cars. So, you know, I've got a $63,000 Hyundai. It has every driver aid. It has competitive range, competitive, you know, time to distance. It's tough to justify spending more money on a car. Now, it's not a perfect car. I forgot to put a rear wiper in it.
That was an option you didn't check.
No, you can't get it. You can't walk up to the car like a Tesla. You just walk up to the car, it unlocks, you get in, you drive. I don't even think you press the button. You just open the door, get in the car, and go somewhere.
That'll come.
Like it. So my car doesn't do that. I don't have a range planner. I don't have battery preconditioning. The Tesla autopilot is in a different league totally. I've adaptive cruise control and lane departure warning, and I've got all the usual sensors, but Tesla goes several steps further. When I drove my first Tesla Model 3, I borrowed it from a friend, and he says, well, okay, I'll email you the key.
Yeah.
What? Email me, so he emailed me the key, and then I just used my phone.
Well,
It's crazy.
Yeah.
But gentlemen, we'll come to the end of our electric vehicle 101 lecture. I'd like to thank the
It's more
master.
like a 300 level course.
Is it a 300?
It's a 300 level course.
300 level course, not a 100 level course. I hope everybody got something out of it.
Wow,
Yeah.
fantastic.
Are you just gonna share the slides or?
I'm going to share the slide deck. It's a really big file, so I'll build one of those.
This is most interesting.
Yeah.
The spreadsheet.
So you know what? I'll give you the spreadsheets, because then
Right.
then you can sort it. But we'll end the seminar, and thank you all for attending.
It's awesome. Thanks, Lawrence. That was fantastic.
It's very good, yeah.
All right, guys. Thanks.